Is my screen is visible to everyone? Hypothesis testing Excel file, sheet number 4. Is it visible?
Yes, ma'am.
Yeah. So today I'm going to cover some important tests which we cover in inferential analytics. See, whenever we are collecting any kind of information, we are 99.9% we are dealing with sample data. And to generalize results drawn from sample to the respective population, we are supposed to take the help of some statistical tests which are known as hypothesis test or inferential statistics. Okay, so as I discussed yesterday as well, what is hypothesis? It's a statement. Before starting any kind of testing, we are preparing one statement with respect to our objective, or we can say it's a statement about the end outcome. Being a researcher, as I discussed yesterday as well, being a researcher, it's our prime duty that we should keep neutral while we are drafting our statement. That's why there are two types of hypothesis. One is null hypothesis, the initial statement which we are drafting. Like for example, in our data set, we are having employees from two locations, Indore and Bhopal. So suppose I am the HR manager and I am interested to investigate, is there any differences between average salary of Indore and Bhopal? So what I have to do, I have to collect the data from Indore employees as well as Bhopal employees. And now I have to check their average salary, and then I have to compare average salary so that I can make a conclusion. Is there any significant difference or not? So being a decision maker, initially I will always draft a statement like there is no significant difference between average salary of Indore location and Bhopal location. Is it clear to everyone? Every time in any of the scenario, you have to draft your null hypothesis of no difference, of no relationship, of no impact. If I want to check the impact of total experience on my salary, so initially I will draft a hypothesis like there is no significant impact of experience on salary. Initial hypothesis is always neutral in nature. Is this point is clear to everyone?
Yes, ma'am.
Okay. Alternative is the just opposite hypothesis of null hypothesis, and it is basically the hypothesis which we are we want to prove, or we are supposing that it will prove. So the alternative hypothesis is known as it is denoted by H0 or H1 or HA, and in our case I can draft there is a significant impact of total experience on salary in the regression case. And suppose if I wish to compare location wise salary, then I will draft there is a significant difference between Indore location and Bhopal location employees' salary. Okay. Now, yesterday I also discussed about two types of errors. See, what is our procedure? We collect the data, we draft the hypothesis. Now, while taking decision, we can make two types of error. One is type 1 error, another one is known as type 2 error. What is type 1 error? S0 is correct, but we still reject the hypothesis. What is type 2 error? S0 is false, but we accept S0. So in both the case, both the errors are dangerous, but we cannot reduce both the errors simultaneously. These two errors is like a seesaw. आप सबने seesaw देखा होगा पार्क में? So these type 1 and type 2 error are like seesaw. Okay, just a minute. So suppose this is seesaw and this side is type 1 error, this side is type 2 error. So suppose researcher try to reduce type 1 error. Kya hoga? Type 2 error will goes high. And if suppose I try to reduce type 2 error, type 1 error goes high. Is it clear to everyone? Type 1 error and type 2 error, both are actually two opposite extremes. Type 1 error is we are rejecting null hypothesis provided it is true. And what is type 2 error? We are accepting the wrong null hypothesis. So both are two extreme endpoints, and we cannot reduce both the errors at the same time. But both the errors are equally dangerous. So universally, it is decided we should keep one error fixed. We should prefix the amount of one error and then try to reduce another error. So suppose this is type 1 error and I fix this type 1 error at some point. Now I can try to reduce this one. Now this point is not free. It is already fixed. So we can reduce the second one. Okay. So universally, it is decided that we should prefix type 1 error. So there are three benchmark levels which are decided: 1%, 5%, and 10%. I covered yesterday as well, but I'm repeating once again. What is the concept of 1%? Can anyone remember that, which I have discussed yesterday? What is the meaning of 1% error? No? Okay. So what is 1%? If I am performing experiment 100 times, out of 100, there will be a chance one time I will commit error. So out of 100, one time chance of committing error, and which error? Type 1 error. Okay. So 1% means 1% chance to commit error. 5% means 5% chance to commit error. 10% means 10% chance to commit error. This pre-decided level is known as level of significance. Is it clear to everyone? Please acknowledge.
Yes, you mean to say the significance error is 1%, 5%, or 10%?
Yes, this is the common values which are universally accepted. Now, just abhi maine bola.
So, ma'am, how do we decide whether in a particular data we'll go for 1%, 5% or 10%?
Harpreet, it is totally researcher's decision. But I'm telling you one thing, universally out of 1, 5 and 10%, 5% is the mostly used value. So most of the research papers you will find researchers are using 5% level of significance.
Okay, ma'am.
And what is the reason behind it? Actually, just imagine if I'm saying 1% type 1 error, means 99% I am confident that my work is appropriate. Yesterday I discussed level of significance and confidence interval. Both are opposite to each other. If error is level of significance is 1%, what will be the confidence interval value? Confidence level?
99%.
99%. So actually 1% is actually a very good value for any kind of research. But I just explained to you type 1 error and type 2 error. Both are opposite. And what is our motive? Reduce both the errors. So 1% type 1 error. What is level of significance? It's the amount of type 1 error. So if I am assuming 1% type 1 error, in that case, type 2 error is high. If I am taking 5% error, type 2 error will goes down. If I am taking 10% type 1 error, type 2 error will goes down. Okay, so 5% is in middle. So at 5%, both type 1 error and type 2 error are actually having some mediocre value. Are you getting my point?
Yes,
Are you
ma'am.
getting? Correct?
Yes,
So
ma'am.
that's why universally type 1 error which we are using is 5%. Okay.
Yes, ma'am. And type 1 error means that we are mostly basing the research on that we are rejecting the hypothesis when it is correct.
Type 1 error is basically when we are rejecting hypothesis when it is correct. Basically, we are I'm giving you a very much easy example. Suppose being a statistics teacher, I'm giving you one numerical to calculate average of some data. And the correct answer is, say, suppose 9.5. And you calculated 9.54. So mathematically, 9.54 is not a correct answer. Am I correct?
Yes, ma'am.
If correct answer is 9.5 and you calculated 9.54, so it is actually incorrect. But can I give you 0 marks for 9.54? Because 9.54 is actually nearly equal to 9.5. Yes or no?
Yes, ma'am.
So I will actually accept your answer and I will provide you some partial marks. Okay. So this is the actually thing. Whenever we are comparing two data sets, exactly equal amount average we cannot receive. But that difference is significant that we are testing. So suppose our difference is actually beyond the acceptance limit, we actually reject our hypothesis. And if our difference falls within the limits, then we are accepting null hypothesis. This is the concept. Should I move ahead?
Yes, ma'am, sure.
Now, please note down this thumb rule. I hope my screen is visible.
Yes, ma'am, yes.
So the selected cell number C8, this is your thumb rule. I highlight the cell by blue color. Whenever we are running any kind of test, we actually calculate one p-value. Now, what is the meaning of p-value? P-value is the probability value of accepting null hypothesis. So whenever we are calculating p-value, if my p-value is less than alpha, now what is alpha? Level of significance. In most of the cases, what level of significance we will be using? Which level we will be using in most of the cases?
5%.
5%. So 5% means 0.05. So you have to compare your p-value with 0.05. If your value is less than 0.05, you reject your null hypothesis. Reject null hypothesis means you are going to accept the alternative one. This is the thumb rule which we have to follow in any of the tests. Is it clear?
Ma'am, can you repeat once again, please?
When whenever we are applying any kind of test, we will receive one p-value. That p-value is the decision point for our test. If our p-value is less than alpha, that is 0.05, then we reject our null hypothesis. Otherwise, we accept it. Is it clear?
Yes, ma'am.
Okay. So now I will going to cover 3 tests in my today's session. T-test, 2 samples independent. I will be covering only those tests which are mostly used in HR scenario. So there are so many tests, but in this particular session, I will be covering T-test, ANOVA. So T-test, there are so many applications, but I am covering T-test 2 sample, which is also famously known as independent sample T-test, pair T-test, and ANOVA, one way. These three things I will be covering in my today's session. Okay. So please move to first sheet, location-wise salary. In hypothesis testing, this is the same data which we will be using, which we are using from past 2 days. So I just segregated Indore monthly salary data and Bhopal monthly salary data. Is it clear to everyone? It is the same data which we have used, employee data set, but I make 2 independent columns by applying filter, one for Indore salary and one for Bhopal salary. Is it clear? Should I start? How to apply T independent sample T test?
Yes, ma'am.
Okay. Now in my sheet number 4, I have given you idea in what situation you have to apply T2 sample test. Suppose after this workshop, if you forgot, please refer this sheet 4. So when we apply 2 sample T test or independent sample T test, when we are supposed to compare 2 independent groups, 2 independent samples. See, we have collected sample of 200 employees of the same organization. But when I segregate these 200 employees based on their location, now Indore location is entirely independent from Bhopal location. Salary of Indore employee doesn't depend upon salary of Bhopal employee. Okay. So whenever I am segregating my sample into 2 parts, Indore and Bhopal, now it will be treating like 2 independent groups. So whenever you are supposed to compare 2 groups, you are supposed to apply 2 sample independent test. Is it clear? So whenever you are receiving situation like this, suppose you are you wish to compare training scores of IT department with training scores of analytics department. So now IT department is different, analytics department is different, and you wish to compare their scores. So which test is applicable? Independent T test. So how to apply independent T test? So before applying independent T test, can anybody tell me what will be my hypothesis in this case? What will be the hypothesis? I wish to compare average salary of Indore location with Bhopal location. What hypothesis I will draft?
Salary for Indore, monthly salary is null hypothesis. And if it is true, then the Bhopal salary will be less.
No. See, I wish to compare salary of Indore with Bhopal.
Okay.
So my null hypothesis would be either I can draft, there is no significant difference between average salaries of Indore location and Bhopal location. Is it clear? Either by this way, there is no difference between average salary of both the locations.
And alternative will be significant impact of this.
Yes, impact nahi. Right now there is we are not dealing with the association of 2 variables. I'm just comparing single variable, which is salary. In both the columns in this sheet, both the columns I am having same variable, salary. Is it clear?
Yes, ma'am.
Another way, if I'm not interested to use the same kind of language, no difference, so I can draft both the locations are having identical or same salary structure. I can draft in this way also. Whenever I am saying there is no difference, means salaries are equal. And whenever I am saying there is difference, it means salaries are not equal. Is it clear?
Yes, ma'am.
Okay. Now, how I will apply the test? I click on data. I click on data analysis. At last, you will find t-test. There are 3 t-tests available here. So you have to apply z-test 2 samples. Now, whenever I am observing z-test 2 sample, there are 2 options: equal variance, unequal variance. So please remember, until and unless you are having the idea of population standard deviation, you should not go with equal variance. So 99.99% we are choosing t-test 2 sample assuming unequal variance. See, whenever we are collecting the data from 2 different locations, Indore and Bhopal, I don't have any idea about what is the standard deviation of all the salaries from Bhopal location and Indore location. See, this is the in-house data. Being a part of that organization, I can collect the complete data and I can calculate their standard deviation. But just imagine a situation in which you are doing some customer survey. You are taking feedback from students or customers or any other kind of survey. So in that case, you are not having complete information with you. It's not possible for you. So that's why in initial assumption, we are assuming that there is unequal variance. So every time you should choose t-test 2 sample assuming unequal variance. Click on OK. This window will pop up on your screen. Please acknowledge. My screen is visible now. This t-test 2 sample assuming unequal variance window.
Yes, ma'am. Yes.
Okay. Now here you have to provide the input: variable 1 range, variable 2 range. अगर कभी भूल भी जाए कि we are having suppose 3rd office at Ujjain location. So if I am having 3 different sample, so t-test will give you hint. Only 2 variable columns are allowed. We cannot compare 3 location data by using t-test. In that case, we will shift to ANOVA. Okay. So variable 1 range means salary of 1 location. Variable 2 range means salary of 2nd location. So I am selecting first cell of Indore salary. Control Shift down arrow key. I put my cursor on 2nd variable. And I'm selecting Bhopal monthly salary. Control Shift down arrow key. Since I selected the heading label, so I am clicking on label. And now below labels, what you observe? What is written over here?
0.55%.
Yes, here it is alpha. So Excel give you option. It is, as I told you, it is totally my decision. I have to compare these average of Indore and Bhopal at 1%, at 5%, or at 10%. This is totally my decision. Or my senior or some company official told me that you please compare on this level. So by default here 0.05 will be reflecting. But if I wish to change, I can change it. Now I'm generating result in new worksheet. So by default, it is selected. I'm clicking on OK. And this hypothesize mean difference, you are supposed to keep it empty. This is basically something we are instructing Excel that itna difference ho to accept karna or reject karna. So we are not doing that. We are going with the test results only. So keep it empty. Click on OK. I hope this result is readable now. The test is generated. I hope everyone is getting same kind of table. This table is generated. Everyone getting such kind of table?
Yes, ma'am.
Okay. Now, please try and understand what we received. Average. Now, average of Indore monthly salary 77,000. Average of Bhopal salary 75,000. This is variance. Variance means square of standard deviation. So, in my descriptive session, I have explained you, higher the standard deviation is lower the stability. So, Indore location standard deviation square is higher and Bhopal's lower. Means Bhopal, there is consistency in data, but in Indore, there is no consistency. How many observation we are observing in Indore? 100. In Bhopal, 100. Now, please keep one thing in mind. There is no need, there is no necessity that both the samples are having equal amount data. It is need not be necessary. By chance, I have created a data in which Indore location I am creating 100 data points, in Bhopal location I have created 100 data points. But in a practical scenario, you deal with two independent samples. So it may be a chance ki in one sample you are having, say, suppose 100 observation, in another sample you are having 50 or 60 observation. It may be possible. We keep empty hypothesize mean difference. So by default, the empty cell Excel will assume 0. Now, this is my p-value. This is the value of t-test which we have run. But you have to take the decision always based on p-value and p-to-tell value. This you are supposed to keep in mind. There are two types of tests, one tell, two tell. I'm not going in that much of detail right now, but the way we draft our hypothesis, there is no difference and there is difference. So if I'm saying there is difference, so there is difference statement is covering both the condition. Either Indore is higher salary or Bhopal is having higher salary. Both the conditions inbuilt in alternative. So that's why we termed as two tell. So every time, whenever you are drafting hypothesis in this way, you just observe P to tail. Now, can anybody tell me, by observing P to tail, what would be my decision? I should accept H0 or I should reject H0? What was the thumb rule? What was the thumb rule? The thumb rule was, if your p-value, if p-value is less than alpha, then reject S0. What is your alpha in this case? What is your alpha in this case?
0.05.
0.05. Now, what is your p-value here?
0.67.
Now, please tell me, 0.67 is less than 0.05?
No.
No. So it is higher than 0.05. It means I'm not able to reject H0. I'm not in position to reject H0. What it mean? What it mean if I'm saying I'm not able to reject H0? What it mean?
We have to accept the H0 condition.
H0 condition. And what was the H0 condition?
There is no impact or there is no difference in
monthly salary, average monthly salary of Indore location and Bhopal location. See, the average salary which we have received, Indore's average salary is 77,000 and Bhopal monthly salary is what? 75,000. So clearly we are observing both are not equal. How much difference in the salaries we are observing? Near about 2,000. 77 and 75, approximately 2,000 difference in both the locations average salary.
Yes, ma'am.
Yes,
but based on the this 2,000 difference, Can I generalize my statement? That is the point. So my data is saying, no, this difference of 2000 is not significant. This difference of 2000 is not significant in our case. Is it clear?
Yes, ma'am.
See, if I'm giving you one example, suppose in this meeting right now, we are 13 people. So suppose I'm asking I'm giving the task to the all male participants that they are supposed to measure the length of some particular bench. Suppose the actual length of that bench is 10 meter. And all the male participants measure it 9 meters. Okay, how much error they have performed while measuring the length of that desk?
1 meter.
1%.
1 meter. So what would be the error percentage in this case?
10%.
1 divided by 10 into 100, that is 10%. But suppose I'm asking all the females that they are supposed to measure the length of, say, suppose one wall in my room. That is, say, suppose 100 meter, that wall is having 100 meter of length. All the females measuring the wall's length 99 meters. Same error, 1 meter only. But now this error percentage would be 1 divided by 100. Why I am dividing by 100? Actual length is 100. Multiplied with 100 to calculate percentage. So now in the case of females, amount of error is same. 1 meter in the case of male candidates, 1 meter in the case of female candidate. But error percentage in both the situation is different. In the case of male, it is 10%. In the case of female, it is only 1%. Are you getting my point? So sometimes we are observing difference of 2000, just like our case. But this 2000 salary difference is not significant. But sometimes in some of the situation, you are observing difference of 10, 20 points. But in that scenario, you will reject your hypothesis because that difference is actually significant in that particular case. Okay, so it is depending upon data to data. You will not get exactly 2 same values. Please remember this thing. But by statistically, you are trying to find out the difference you are observing, that difference is significant or not. And that difference is significant if p-value is less than 0.05. That difference is not significant if p-value is greater than 0.05. I hope this concept is now clear to everyone.
Yes.
Now we will moving to the second test. Say suppose ANOVA. Just a minute. I hope my Excel sheet is visible. Performance and salary sheet. Hypothesis testing, performance and salary. Sheet is visible?
Yes, ma'am.
Yes.
Yes.
Okay. Again, I am using same data, employee data set. In my employee data set, there is one last column, performance grading, performance rating. So there are 4 performance ratings are there: below average, average, good, and excellent. So what I have done, I have applied the filter. In one column, I have noted down salary of employees who are getting the performance grading below average, salary of employees which are getting the grade average, good, and excellent. So now, can anybody tell me how many samples I am dealing with? How many samples I am having in this case?
4.
4.
Great.
So t-test is having limitation. Whenever we are supposed to compare two groups, t-test is t-test is applicable. But if we are having more than 2 samples, like Indore, Bhopal, and say suppose Chennai location, so we cannot apply t-test. On more than 2 samples, there is one test which is known as ANOVA, analysis of variance. So more than 2 samples if you are having, you are supposed to shift on ANOVA. There are 2 types of ANOVA which are you can use, but in our case, ANOVA single factor. We wish to compare only salary based on 4 performance grading. So which ANOVA is applicable? ANOVA one way. Apart from this ANOVA, there are another ANOVA is ANOVA two-way and ANOVA two-way with replication, ANOVA two-way without replication. So this is actually in most of the HR scenarios, we are using ANOVA. In ANOVA two-way, we are comparing 2 variables simultaneously. So that is not that much of needed. We can compare variables independently. So most of the time we are applying ANOVA one way, which is provided in Excel with the nomenclature ANOVA single factor. So should I start to demonstrate how to apply ANOVA one way?
Yes, ma'am.
Okay. So can anybody tell me what would be my hypothesis in this case? This is these numeric figures are salaries. So what would be my hypothesis in this case? Yes, anyone?
Ma'am, can I try?
Yes, yes, please.
No significant difference in the average good and excellent salary.
Okay. And what would be the another alternative?
There is a significant difference in the average good and excellent salary.
So I can draft it. There is no significant difference between salaries of different performance grade employees, and alternative could be if you are saying there is significant difference, I'm not saying it is completely incorrect, but in the case of ANOVA, you should draft at least salary of one performance grading employees is different. See, whenever we are comparing 2 samples, either both are equal or both are different. But whenever we are comparing 3 or more than 3, so if one of the group is showing different behavior, there it will create difference. It is need not be necessary that below average should be different from average, average should be different from good, good should be different from excellent. चारों का अलग होना जरूरी नहीं है. चारों में से एक भी अलग हो गया, if one of the category out of 4 will be differing, it will create difference. I hope you people are getting my point.
Yes, ma'am.
Okay, so you can draft in both the ways. There is no, I'm not saying that one is wrong. So average salary of all the grades are same, and average salary of one of the grade is different. This could be your hypothesis. So how I am applying it? Click on data analysis, click on ANOVA single factor. Click OK. Now here, instead of variable 1, variable 2, now you are observing it will ask you input range. Because
Ma'am, it's not showing. It's like the previous one. Yeah, it's a pop-up, right?
Pop-up is not showing? Just a minute.
Yes.
Just a minute. Now
Yes, ma'am.
my
Yes.
data analysis window is
Yes, visible.
visible. So I have selected ANOVA single factor. I click on OK. Now this window is visible. ANOVA single factor input range.
Yes, ma'am.
Yeah. So in t-test, it is clearly mentioned variable 1, variable 2. That was the hint from Excel. If you are having only 2 columns to compare, then use it. But now here, if you have more than 2 columns, you can 3 samples, 4 samples, 5 samples, 25 samples, you can apply ANOVA one way. Is it clear to everyone?
Yes, ma'am. Yes.
Yeah. So now I have to provide the input range. So I select first cell that is below average. By clicking on shift and right arrow key, I select first cell of all the 4 columns, and now control shift down arrow key. Now you just check here up to row number 25. My one sample is finished, but the another samples are having few entries. So I am pressing shift and down arrow key. I am pressing shift and down arrow key because this is the actually practical scenario. I collect 4 different samples, and all the samples are having different amount of data. Every time it is not possible that my each and every sample is having equal points. So it is acceptable if one sample is having few data points, another one is having a different number of data points. First row is a label, so I select label in first row. By default, alpha value is 0.05. My data is segregated into samples. It is grouped by columns. By default, it is selected. I am generating my result into new worksheet. Now I am clicking on OK. The sheet number 2 is, do you get the same kind of results?
Yes, ma'am.
Yeah. Now, just try to understand what we have received. We always receive 2 tables in ANOVA. First is summary table and second one is the ANOVA test result. So in summary table, it will give us idea what how many samples we have compared. So we have compared 4 samples: below average grading, good, and excellent. How many data points in below average? 24. Means out of 200 employees, 24 are having below average grading, 58 are having average grading, 58 are good, and 30 excellent. So this is actually sign of normal distribution. The poor rating and the excellent rating are available for very few employees. Most of the employees are getting average or good ratings. So most of the employees are getting these 2 ratings. Okay, extreme ratings are having allotted to very few employees. Now move to ANOVA table. In ANOVA table, this is sum of square, this is degree of freedom, and DF, mean sum of square. I told you in my earlier session, ANOVA based on F-test. So it is the value of F-test. So you just ignore all the values and just remember my thumb rule, which I have provided you. P-value thumb rule. What was our thumb rule? If P-value is less than level of significance, 0.05, then only we are in position to reject the hypothesis. Can anybody tell me what would be my decision over here? What would be my decision? What would be my decision? My hypothesis is...
We have to reject H0.
No. Here it is
0.16.
0.16. And what is my level of significance? 0.05. 0.05. So this value is greater. 0.16 is greater. Are you getting my point? This is 16%. This is 5%. 16% is greater than 5%. If here I will get 0.01, then I should reject my hypothesis. Is it clear?
So, ma'am, we accept the null hypothesis.
Yes, we accept null hypothesis. We are not, see, salary is different. You can check. The below average employee is having average salary of 70,000 and excellent is having 85,000. 15,000 ka difference hai. But this 15,000 difference is not that much significant in our organization. I hope you people are getting. There is difference, but this difference is not significant that we should generalize this statement ki grading is making significant difference in our salary structure. Is it clear?
Level of significance is standard 0.05.
0.05. Please pay attention on the decimal value. 0.05. This is what 16 by 100. This is what 5 by 100. Now compare the numerator.
Ma'am, I'm asking level of significance, that is 0.05. It is the standard value which we need to compare.
Yeah. Level of significance is the threshold limit by which we are comparing our p-values. Mostly, there are three values which we are using: 1%, 5%, and 10%. But universally, mediocre value 5% is acceptable.
Okay.
Okay. Now, the last thing which I want to discuss, and it is actually very much important in HR scenario, that is pair t-test. Most of the time in HR, we are conducting trainings. So whenever we are conducting training, our objective is training is impactful or not. So this is one data set. I hope my screen is visible. This is the data in which I have collected data of training scores, pre-training score, post-training score. Is this sheet is visible to everyone?
Yes, ma'am.
Okay, so please listen me very carefully. There is one option in t-test which is known as paired t-test. Now, what is the concept of paired t-test? It is applicable in the situation when we are having data of before and after, pre and post, pre-COVID, post-COVID, pre-training, after training, post-training. But in this case, sample will remain same. Suppose right now, if I am taking your test, and now I am giving you some special training, and after training, I will take another test. So if your test marks will improve, it will show my training is impactful. And if there is no significant difference in marks, I will say your training is not that much of impactful. Okay, so in such kind of scenario where sample is same, but you have collected information from the same sample at 2 points of time, pre-test, post-test, pre-training score, post-training score, pre-COVID, any kind of feedback, and post-COVID, any kind of feedback from the same person, you can apply pair t-test. Okay, so just a minute. This is dummy data. You please make a change in last observation, 10th observation. In place of 76, you just make it 76. Okay, because it's my dummy data. So I'm getting some issues in the data which I have shared with you. So just change the last observation. Okay, now I am applying the test. Click on data, Acha, can anybody tell me what would be my hypothesis in this case? What would be the hypothesis?
Ma'am, no significant difference between the pre-training score and post-training score.
Very good. There is no significant difference between pre-training scores and post-training scores of employees. An alternative one is there is difference. Or in other words, we can draft training is having no impact on performance and training is having impact on performance. Suppose training scores are post-training scores are higher, then we can say that training is having impact on performance. So I hope my data analysis window is visible.
Post-training score is higher than pre, so it should be like it is impactful. Training is impactful.
Yeah, so post-training scores should be higher. But again, the same thing. Are the scores are that much higher so that I can generalize my result? There is significant difference.
Okay.
Again, the same concept. 5 marks or 2 marks difference might be are not that much impactful. Okay, so that we need to cross-check. We are observing post-training scores are higher. We are observing, but is this particular difference is significant or not? That we are checking right now. Okay. My data analysis window is visible to everyone.
Hello.
Yeah. So I am selecting t-test pair to sample. This window will pop up again. Pair t-test.
No, ma'am.
No, just a
Pop
minute.
up is not.
Okay. Just a minute. Now tell me, I'm clicking on data, clicking on paired sample 2 means. Now this window will,
Yes, ma'am.
yeah. So again, it's t-test. It will give you only privilege to compare one variable to other. So whenever I'm talking about pre and post, obviously there will be only 2 columns. And again, now in T2 sample independent, it can be possible that sample 1 and sample 2 are having different number of observations. But whenever you are applying pair t-test, number of observations should be equal. It is the data from the same respondents. If you have collected data of 10 employees, from the same 10 employees, you need to collect the post data. Click on labels, alpha 0.05, new worksheet, click on OK. This sheet will be appear on your screen. Okay. So average from pre-training is 65.6. Average from second training is 74.6. Clearly, we are observing increment of 9 points. But as per the P2 tail, now we are supposed to comment. Can anybody tell me what is my P value over here? What is my P value over here?
4.2690.
P value. P2 tail.
Okay.
Every time we have to observe P2 tail.
8.53.
It is not 8.5. If in any of the cell you are getting this E-06. E-06 means 10 to the power minus 6. 10 to the power minus 6 means you have to divide 8.5 by 10 to the power 6. It means it is 0.5 times 0.85. You just do this thing by using calculator. 8.5 divided by 10 to the power 6, you will get this value, which I am typing over here. 0.5 times 0.85. Now tell me, this value is Greater than 0.05 or this value is less than 0.05?
Less than.
Less than. Now tell me, what would be your decision?
We will reject.
We are rejecting our null hypothesis, means there is a significant difference in pre-training score and post-training score. Now you are supposed to comment which training score is higher. Post-training score is higher. It means training is impactful. I hope this is clear to everyone.
Madam,
kindly repeat it once again.
Your pair t-test is applicable in the case of whenever you are collecting pre and post information from the same kind of respondent. Okay? So you have collected pre-training score and post-training score. You apply pair t-test. Now this is your p-value. If in any of the cell you will observe this E-06 or 05, E dash means E stands for exponential, means 10 to the power. If you are observing dash 06, this is not dash, this is minus. So 10 to the power minus 6. So basically 8.5 multiplied by 10 to the power minus 6. 8.5 multiplied with 10 to the power minus 6 means 8.5 divided by 10 to the power 6. And actually it is very, very low. It is very low. It is approximately equal to 0. So it is clearly less than 0.05, your p-value, and hence your null hypothesis should be rejected. Rejected means your training is impactful, your post-training scores are higher than pre-training scores. Is it clear now? Okay, so this is all from my side. I covered the descriptive statistics which is required for the HR perspective. I covered the correlation, regression, and hypothesis testing. In hypothesis testing, there is so many of the tests, but I covered only those tests which are actually required for any kind of HR decision making. So I hope you all get the sufficient idea, and you please practice the sheets which I have shared. And I have given the idea in which situation what kind of test is applicable. That is available in sheet 4. Same in descriptive statistics. At the last, it is mentioned when we should apply mean, median, or mode, or any other tool like correlation and regression. So this is all from my side. I hope you people enjoyed it.
Madam, excuse me.
Yes, Kishore.
Actually, when one tail t-test is being applied.
One tail t-test is applied when we are preparing our alternative hypothesis in this way. Indore location is having better pay structure as compared to Bhopal. We are talking in one direction. Whenever we are saying there is difference, so there is difference means either Bhopal is having high pay structure or Indore is having a higher pay structure. But we are saying if we are drafting our hypothesis, Indore is having higher pay structure rather than Bhopal. This is one-sided only.
Okay.
So practically we are not using one tail. We are considering both the ways, both the situations. That's why mostly 99% we are applying two tail. Okay?
Okay, thank you, ma'am.
Okay. So I am leaving this session.
That means we can say that our prediction of the better pay structure towards Indore is more dominant and confident. In that case only we apply one tail.
Yes, yes. If you have that much of confidence that like in our case, I can draft one tail as well. The post training scores are higher than pre-training scores. I can draft, but it is always suggested
ये research methods से related है,
should be
उससे
open.
और कुछ नहीं.
हाँ.
Yeah, we should be open to both the results.
Now I'm leaving the class because Rashmi ma'am is waiting. है ना? So you people please continue with the Rashmi ma'am session.
Thank you so much.
Bye.
Thank you so much, ma'am.
Okay. Thank you, Bhushan. Thank you.
Thank you, ma'am.
Okay.
Physical. Good morning, ma'am.
Good morning, everyone.
Good morning, ma'am. Good morning, everyone.
Good morning, everyone.
So today is the last session, and I'm just sharing. I've shared the data sheet with every one of you. So please download the data from WhatsApp group. All of you have downloaded the data. Yeah. Okay. So in the last class, we had a discussion about descriptive analytics and diagnostic analytics, and we have done a few case studies related to the same, right? So today I'm taking another case study which is related to predictive analytics, right? What is predictive analytics? Any one of you can? Yes.
What happens in the future? Predicting what happens in the future based on the past data.
Yeah, what will happen in the future based on the past data. So we have worked on case studies basically related to what happened and why it happened, right? Now we will be working on what will happen, right? So I've taken a case study. It is based on compensation data, and this is about the STA IT services. John was hired as an HR analytics manager at STA IT services, and STA is one of the well-known company, and they hires hundreds of IT executives and managers for their consulting business. So basically, this company is into the consulting business, and for that particular purpose they are hiring hundreds of IT executives and managers. John's team invests a huge amount of time and analyze time and effort in analyzing each and every resume to calculate the joining CTC or salary for new hires. Means basically what is happening is whenever they are hiring the new people, they are supposed to check out the resume, compare those resumes, like compare the experiences of those people, compare their past salary with the employees who are already working with the company, right? So whenever they are supposed to hire anybody, they are supposed to do lots of work while deciding their salary, right? Because they have a manual system of deciding the salary. And as we all know that being a compensation manager, it is also very important to maintain the parity, right? So if you are hiring somebody and somebody is already working on that particular role in your company, so you need to check whether what salary we are paying to that person based on their experience, based on their past, their training, their skill, everything, their qualification. So there are multiple parameters that we are considering while deciding the salary, right? And maintaining the parity is also something that is very, very important. And it happens many a time. Like suppose somebody is working with the organization for since 10 years and they are on the salary of, let's say, 60,000. There is a new employee hired in the company on the same profile. Experience is less, but that person is getting higher salary than the one who is having already working with the company, right? Many a time it happens. People with 15 years, 20 years of experience are getting lesser salary, but the one who is hired in an organization, they are with a lesser number of experience, let's say 5 years or 10 years of experience, they are getting more salary than the one who is already working. So this is one of the issue that most of the organizations are facing, right? And that's the reason maintaining parity in compensation is very important. So whenever a new employees are hired in the company, what this company is doing, they are comparing their resume with the people already working in the company, what they are paying to them, and accordingly they are deciding the salary to be offered to them. So that manual task is too cumbersome. Now John has recently completed a course in analytics and machine learning, and he is thinking that what he should do, or how he can use the machine learning to use past data to create a data-driven process for setting CTC for the new hires, right? So how he can predict the CTC by comparing the basically the resume of current candidate with the employees who are already working with the organization. So he want to automate that system of deciding the CTC for the new hires, right? And for that purpose, what he did, I have shared one data sheet with you. All of you have that sheet with you? Yes? Open that data sheet. I hope the case study is clear to everyone. The case is clear?
Yes, ma'am.
John want to predict the CTC of new hires based on the past data of employees who are already working with the company. So now tell me, what can be the factors that organizations are considering while deciding the CTC of any employee? What can be the factors?
It can be the current trends and the caliber of the candidate.
Okay, skill level, we can say skill set of the person is one thing. Current trend means what other industries are paying, right? We need to maintain external equity also. Other than this?
Perhaps the paying capacity of the company also.
Yeah, paying capacity of the company, good. Anything else? Yes?
Experience.
Past experience of the employee, good. Any other factors? So, just a minute. Is the data visible?
Past CTC of the candidate and percentage of hike to be given to that candidate.
Yeah, past CTC of the candidate and percentage of the hike given to the candidate. I'm just facing some problem with, just a minute. Okay, past CTC is one thing. Okay. So, this data sheet is visible to every one of you. So,
Yes.
basically, this data sheet is comprising of variables like, for example, like the past CTC of the employees. It's given the employees who are already working in the company. They have taken multiple factors, like from which college that particular candidate was hired, that employee was hired. So they have given the college category, then they have given the role, for which role the employee has been hired, for which city, because location wise also salary varies, right? So for which city they have hired, what was the previous CTC of the employee when he was hired in the company, what was how many jobs he has changed in the past years, right? Then what was the graduation marks out of 100? What is the experience of, what was the experience of employee in months? So they have taken certain variables. So first of all, what I'm doing is I'm selecting this data and I'm applying filter on it. Either you can use Control Alt T, just a minute. Yeah, or you can directly apply the filter from here. So if you see in college category, they have given three different categories. Tier 1, Tier 2 and Tier 3. So Tier 1 college may include, let's say, top 10 B schools across India, top 20 B schools across the India. In the similar way, A category, B category and C category colleges, they have taken in Tier 1, Tier 2 and Tier 3 category. Then they have taken the role, whether the role is executive or it's manager. Then they have taken city type, for which city type the employee was hired, whether it is for metro or whether it is for non-metro. Then what was the previous CTC of the employee? They have given the CTC that employee was getting before he joined the company. Then they have given the information about how many jobs he has changed, graduation marks out of 100, experience in months, how many months of experience the candidate was having, employee was having, and this is the CTC that was offered to that particular employee. So if you want for, suppose if you want to add more variables, you can add this to this particular data sheet. I have considered few variables which are impacting the CTC. So this is a dummy data of count. How many employees? It is a dummy data of 1,338 employees, right? So what we need to do is we need to predict the CTC for the new hires, right? Based on considering these variables in their resume. So what I will be doing before I analyze this data, I need to convert this categorical variable into numerical data. First of all, we will be doing the pre-processing of the data. So just click on right click, then move or copy, move to our end, create a copy. Okay. All of you have created the sheet. Then rename it as pre-processing. All of you have done it? Done? Now what I am supposed to do is I need to pre-processing the data, means I need to convert this data into the categorical data into the numerical data. So first of all, I am taking college underscore, there are 3 categories in college category, right? Tier 1, Tier 2, Tier 3. So we will be creating 2 dummy variables for it. If the college is Tier 1, then 0, otherwise 1. If the college category is Tier 2, then 1, else 0. If college category, if there are 3 conditions, then we need to create 2 dummy variable for the same. So when we will be creating 2 dummy variables, third automatically the software will understand, right? This is college underscore 1. Now apply function if this equal to Tier 1, comma 1, else 0. So what does it mean? If this B4 column equal to Tier 1, then 1, write 1, else write 0. Enter. Then you need to just click over here. So wherever there is a Tier 1, the system will automatically take 1. Right? Wherever there is a Tier 2 and Tier 3, it will take 0. All of you are doing it? Yes? All of you are doing it with me? Should I proceed further? Yes?
No, ma'am. Wait for 1 second.
Now
Tier
repeat
1
the formula.
only do 1, 0.
Yeah. Again, I'm showing you what I have done. I have applied equal to if B4 equal to double inverted comma, right? Here 1, I told you Excel is always case sensitive. Then 1, else 0. Else 0. Enter. And then you need to just press over here. Wherever there is a Tier 1, the system will automatically take it as 0. 1, and for others, it will assign the value 0. Now we will, as I already told you, there are 3 conditions. We'll create 2 dummy variables here, Tier 1 and Tier 2, right? So college underscore Tier 2 means if the college category is Tier 2. Again, we need to create a condition if this equal to double inverted comma Tier 2 inverted comma, then 1, else 0. If this equal to Tier 2, then 1, else 0. Press enter. Just a minute. There is, I have given a space. Yeah. Okay. If this equal to Tier 2, then 1, else 0. Just press on it. So wherever there is a Tier 2, it will take 1. For Tier 1 and Tier 3, automatically the value will be 0. All of you have done it? Done? Done? Please reply. I'm not able to understand.
Value 1 or 0 नहीं आ रही.
Don't give any space. Just write equal to if, just click here. This B4 cell you need to select equal to double inverted comma, right? Tier 2, then comma 1, else 0. This is the formula. All of you have done it? Done? I'm not able to get it whether you people are done
Yes.
with this one. Yes? Should I proceed? Now, for this particular condition role, we need to create a dummy variable for the role. So there are two categorical variable here. one is executive, and the one is manager. So what we need to create one dummy variable here because there are two conditions. So role underscore manager. What will be the formula we need to use here? Equal to if this equal to double inverted comma manager, then 1 else 0. Right, so wherever the role is manager, it will take it as 1, and wherever it is executive, it will take it as 0. Right? Now we will create a dummy variable for city type also. So in city type, we have either metro or non-metro. So we'll take city underscore metro equal to if this equal to metro, then 1 else 0. This is the formula that I have written over here. If D4 equal to metro, then 1 else 0. Click over here. So wherever the city is metro, it will take it as 1. Wherever it is non-metro, then it is 0. And try to understand whenever we are creating a machine learning model or whenever we are going for using we are creating a predictive model, we need to check whether the data is complete or not. If any of the column is, any of the cell is empty, then you will not be able to get result, right? So you need to check whether the data is complete or not. You need to convert the categorical data into the numerical data. This way, you can apply the if conditions. Now, if you see here, we have our data in numerical form, right? So this, what is the dependent variable over here? What are the independent variables? Dependent variable is what? It is, if we see this data sheet, what is our dependent variable? Yes? Are you there?
CTC?
CTCs are dependent variable, and independent variable is?
The rest of the columns.
Yeah, the rest of the columns are the independent variable. Now what we need to do is, we need to apply regression on this data, right? So just go to data analysis, select regression. Y variable is what? The CTC. Y is our dependent variable and X is our independent variable. So here we are applying multiple regression, right? Linear regression, multiple. Now what I am doing is I am selecting Y variable. So put your cursor on this CTC, Control Shift down arrow. Right? We have selected all our dependent variable over here. Now input X range. What we will be doing, we will be selecting your cursor on college shift, select all the independent variable till experience, Control Shift down arrow. Okay. Have you selected the range? If you see, it is M1341, E1341. Yeah? All of you have done it? You're not replying, so I'm not able to get it. But, yes?
Yes, ma'am. Yeah.
All of you have done it? Must are you able to see whatever I'm doing? I don't know. Have you applied it? Regression? Press? Click on labels and confidence level 95%. Okay. All of you have got this regression table? Got it?
Madam, the sheet is not visible. Right, yes.
It is visible or not? It's not visible? Are you able to see the regression table or not?
Yes, ma'am.
Yes, okay, I'm sharing it again. Yeah. This is the regression table. I have applied the regression between CTC and all the independent variables which are affecting the CTC of employees, right? So if you see here, the value of multiple R is 0.779. R square value is 0.608. Adjusted R square is 0.605. What we can interpret out of it? What we can interpret?
I think so. The Prashmi madam has lost her connection.
Is the screen visible to all of you?
Yes, ma'am.
Yeah. So I hope you
ma'am.
understood how I have marked this. We have checked the value of p-value of this, and then based on that we have identified which independent variable is having an impact on the dependent variable, right? So we have seen that for college tier 1 the value is 1.2 exponential to the power minus 17. It is very, very less than 0.05. So we can say that when the college category has been changed from tier 2, tier 3 to tier 1, the salary has been there is a significant impact on the salary, CTC. So this way we have identified the p-value for all these variables, and we have identified which are the independent variables having an impact on the CTC of the employee. Then how we can interpret this college tier 1. So coefficient, you all know, is the measure of independent variable. So with the change in value of independent variable, how much it will impact the dependent variable, you can calculate it. So college tier 1, if means when the college category has been changed from tier 2, tier 3 to tier 1, the salary has been increased by 4,659 rupees. This is what we can interpret from this. When the role has been changed from executive to the manager, the salary has been changed by 19,359 rupees. Similarly, when the city has been changed from non-metro to metro, the salary has been changed from by 4,080 rupees. When the previous CTC is increased by 1,000 rupees, the salary will be changed by 451 rupees. When experience has been increased by 1 month, salary has been increased by 58 rupees. Yes? Yes? Any questions? This way we can interpret this, right? Now what we need to do is, we will select all these values of coefficient, select it, go to pre-process data, and put your cursor on city type, that is non-metro one, paste spatial transpose. Done.
Madam, we have lost connection whereas I haven't seen how you have done the regression equation.
Just a minute. Have you applied the regression on this data?
No, ma'am.
No, you have not applied. So what I have done is, I have gone to this data column, data analysis, select regression, press OK. Right? Then you need to select input Y range and input X range. So input Y range, what I have selected column right from CTC. CTC column I have selected.
Right.
Then for input X range, I have selected college T1 to experience, all these X variables, right?
Okay.
And then I have checked on labels, confidence level. Okay. So you will get this regression table,
Okay,
right? You got it?
Yes, ma'am.
Then we have checked for the model fitness. So the value is 0.60. Multiple R value is 0.77. It is said that if the adjusted R square and R square value is more than 0.45, we can consider model is fit for use, or regression model is accepted for the use. Then what we have seen, based on this P value, whether it is less than 0.05, then there is a significant impact of this variable on the CTC. Wherever the value is more than 0.05, we found that this variable is not impacting the CTC, right? Then what I have done, I have selected this coefficient values. This is our beta values. Then I have pasted it here. This is our beta value. Then this is our B1, B2, beta 3. This way I have the coefficient value of all these x variables, right? This is our x1, x2, x3, x4, x5, x6, because as you all know that the regression equation is a plus bx. So if there is one variable, then we can easily say this beta value plus b1, x1. But we have multiple variables over here, multiple independent variables, and that's why our regression equation will be like a means b, this is the a value basically. A plus beta 1 x1, beta 2 x2, beta 2 x1, beta 3 x1, beta 4 x4, right? So this way we will be taking the variable, right? Now, what we need to do here is we need to predict the CTC for the future hires. Predictive CTC. I told you predictive CTC is not something that is the exact amount, but it will take you closer, right? So how we can calculate? We will create a regression equation over here equal to, we'll select the A value, right? Plus this beta 1 into x1 plus beta 2 into x1 plus beta 3 into, this is the variable, plus beta 4 into this variable we have taken, plus beta 5 into this, plus beta 6 into this, plus beta 7 into this, this, plus beta 8 into this. All of you have calculated, all of you have created this regression equation over here. Done? Press enter. बस ये finish करके all of you have done it. Done. All of you have calculated the predictive CTC. I'm not able to get you.
No, ma'am, wait for 1 minute.
Okay. Done?
No, how we have checked that the regression model is fit? Can you please describe it once again?
This value, as per statistical description, it is said that if the R square or adjusted R square value is more than 0.5, we can say that the model is fit for use. For in our case, it is 0.60. It is more than 0.45.
Thank you, ma'am.
Right? Okay.
Okay,
So all
I'll
of
check.
you have prepared this regression equation, created. Then press enter. Now see, when you directly drag it down, it will not give you any value, right? So what we need to do is we need to freeze our coefficient value here. To freeze the coefficient value, what we need to do, you need to select this coefficient and control, press function Fn F4. Dollar sign we need to put over here, right? Fn F4, select this, Fn F4. Select F2, Fn F4. select G2, function F4. H2, function F4. I2, function F4. J2, function F4. K2, function F4. L2, function F4. All of you have done it? Just a minute. Put $sign. So $sign will make this coefficient value constant, because when we go down to the this particular sheet, the value of X will change, right? And that's why what we have done, we have freezed this value of coefficient, but rest of the other value will change when we move down the sheet, right? Columns, we can say. So now what we need to do, we need to drag it down. You will be able to get the predicted CTC for all the employees, right? Now, suppose all of you have done it. All of you have done it. Yes. Now, suppose if there is a new hire, new candidate, you have who has gone through the whole process of selection, and now you are supposed to offer him CTC. Or suppose you want to decide the CTC of a new hire. Let's say I'm taking the another employee to whom I am going to hire, and I have to decide the CTC for him. So let's say that candidate is from tier 1 college. The role on which I have hired him is executive. I hired him for the location metro. The previous CTC that automatically that you cannot change by yourself. Suppose the previous CTC of that employee was, let's say, 60,000 rupees. And from the resume I have written the number of jobs he changed, let's say it's 2. The marks he has got out of 100 is, let's say, 80. And months of experience was, like, let's say it is 52 months. Automatically, the system will will predict the CTC for the new hire. Means if the new hire hired from tier 1 category college and you are hiring him on executive role, that too for the metro city, his previous CTC was 60,000. You just need to put the information about the candidate. You will get the CTC that you are supposed to offer to that particular employee. I hope you got it. We have predicted the CTC of current, the one whom we are going to hire based on the past CTC of the employees. Yeah? This way, so in the similar way, you can take it for some other employee also, tier 2 manager. So automatically the system will calculate. Non-metro, previous CTC is 50,000. Job changes was 4. Marks was 50. Months of experience was 34. Just a minute. Yeah. So automatically, the system will calculate the CTC, that is 82,000 we need to pay to him. I hope you got it. So this way you can apply.
Ma'am, it can give us some idea about what we can offer him in terms of CTC. However, his performance in the interview would still matter.
Yeah. There are multiple other factors. If you see here also, there is some difference in the predictive CTC of this employee also, right? We consider that apart from this factor, because there are multiple other factors also will affect our CTC that we will be offering. That can be the industry trends, right? Because last year the industry trend was different and this year the industry trend is different. So we will be considering that. We will be considering the negotiation ability of the candidate also. He is able to negotiate and that's why we are offering him higher salary. There can be some other factor also. So definitely we will consider some other factor also and that will affect the CTC. But when you will be calculating it based on past data, you will be able to understand as per our previous employee, we are supposed to offer them this much. So accordingly, you will be deciding how much to increase. Because when you will be increasing there is a huge difference between the salary of the employees working since 20 years and the one to whom you are hiring at having an experience of 10 years. Suppose if you are giving 50% more than this particular person, then it is wrong, right? The morale of other employees will go down. So you need to take care of these things also.
Yeah,
I hope you got it.
Yeah, this provides us some base.
Yeah, this provides us some base.
Yeah,
definitely. It will provide us some base. It is not exact amount because there are multiple other factors also that we need to consider. So today, like I told you, we have workshop as I was supposed to take the class at 9:45, but just because Shweta ma'am extended, so I'm not able to take the part of HR report right now. So I'll plan another session for the same and I'll inform you about the same. Okay? It's just 15 minutes, or if you want, I can just share the format with you so you can refer to that as well. Whatever you say.
Madam, kindly share this sheet of yours to us.
Yeah, I've shared. Okay, the sheet that I have prepared.
Yes, madam.
Okay, I will share that on WhatsApp. So for today, I'm just winding up the session because we have to go somewhere else for the workshop. So thanks a lot, and we'll talk on WhatsApp then. Okay. So hope you have learned.
Thanks, madam, for giving us the exposure about all these things which we are not aware of. Thank you so much, ma'am.
Yeah, thank you. Thank you so much, everyone. It was nice interacting with all of you.
Thank you, ma'am.
Thank you. Thank you, everyone. So I will share the details, the remaining details with you, right? The remaining content. And if I have video of HR reporting, then I will share that. Okay. Thank you. Thank you, everyone.
Thank you, ma'am. Thank you.
Thank you, ma'am.
Thank you.